So this is the Quanser Smart Grid demo. This demo includes 3 Elvis engineering top boards. This one is the energy conversion top board. We have 3 of these top boards. One of them representing a conventional power plant, which is this one here, where we have a spinning motor, which represents a power source. It could be a gasoline turbine, and that goes into a 3-phase generator that gets rectified, boosted, and then inverted back onto the grid, and that produces our grid frequency. You can see here on the display. Right now it's at around 120 hertz, just fluctuating around there. We have our second energy conversion board. This one, it represents a solar panel. This is our solar panel here, which is being measured by the MyRio. The data on the solar energy gets sent to the energy conversion board from the MyRio through our IoT network. So that tells this board how much energy is being created. And this does that same process again, where it takes that DC power, boosts it, and then rectifies it so it can go back onto the grid. Sorry, inverts it so it can go back onto the grid at the same frequency. So if you can see here, we're sending data back and forth between all of those different systems so that they're trying to match that line frequency. And then finally here we have a wind turbine where you can boost the power a little bit here. You can see the lights get a little bit brighter, and then that sends a little bit more wind power into the grid. This has the full sequence of going from the power generation through the generator and then rectified, boosted, and inverted back again. And then over here we have our Mechatronic systems trainer. This represents our industrial load, which is pulling power from the grid. And what this is doing is learning shapes and then following those shapes, so that it represents kind of a typical industrial process where you'd be teaching something with a teach pendant how to follow a particular path and then using the robot to follow that path. Depending on how quick the robot is moving, we're pulling more or less load from the grid, and that power comes from either the conventional power system, which is in red here, or the green power system for solar, which is in green, or the wind-powered system, which is in blue. So you can see those lights turning off and on a little bit depending on what's going on our green system. And then this dial here is showing how much power is coming from conventional versus how much power is coming from solar or wind. So if I were to spin the little turbine or add a little bit of a flashlight or something in front of the solar panel, you would see the power load skew towards the green side, which is greener energy, rather than the red side, which is conventional energy. So what we're trying to show here is basically you can take a whole collection of our Elvis Rio top boards, connect them all together with a couple of MyRios, and build a really interesting, really exciting real-world application of a smart grid that can teach students all sorts of topics having to do with both smart grids, but also IoT, industrial systems, and how you would build those up into a network infrastructure. Thanks very much.